Okay, we're starting lesson 6.3, and to start lesson 6.3, I just asked everybody to do this warm-up. So if you haven't done the warm-up, you might stop the video, start the warm-up. So let's go ahead and multiply these. So we multiply using FOIL, right? So what did you get when you multiplied this out and simplified? Right? And what did you get when you multiplied these out? And what about here? Wait a second. Should get minus x minus 6 for number 3, right? And this one, you would get x squared plus x minus 6. Is that what you got? Okay. Now let's look at some patterns and let's look at some signs. So factoring is the opposite of FOILing. When we multiply, you FOILed, okay, and you combine like terms. What do you do to 2 and 3 to get 5? Add them. What do you do to 2 and 3 to get 6? Multiply them. Adding -2 and -3 gives you a -5. Multiplying a negative times a negative gives you a positive. So whenever this number is positive, you had the same signs. Okay? So if you see a positive, positive, that means they're both positive. If you have negative, positive here, this means they're both negative. So these are both negative, and this is both positive, right? This is going to be important for factoring. Now here, they had opposite signs. What do you do to 2 and -3 to give you -1? Again, you add them, right? What do you do to 2 and -3 to get -6? Multiply them, okay? Here you have a negative, negative. The fact that this sign here is negative means that the signs were opposite of each other. And we basically subtract those numbers. I mean, they have different signs. We add them together, but the difference is going to be negative. The bigger number is negative. Here we have two opposite signs. -2 plus 3 gives us a +1. -2 times 3 gives us a -6. So anytime the last number is negative, we're going to have opposite signs. And here, when this is negative, your bigger, and I put bigger in quotes because technically -3 is not bigger than +2, but your bigger number is negative. And when you have a positive here, your bigger number is positive because we're thinking about the differences, okay? Why do we do all of this looking for patterns? Well, the main thing about what we're trying to do now is instead of multiplying two binomials together, we're going to be given the trinomial and we need to figure out what the two factors were. That's what factoring is, okay? So it's the opposite, it's undoing. Basically, you know, you think about yourself as a mathematician. You're like Hansel and Gretel. You need to be able to get to the house, but you also want to be able to get home. So you need to be able to undo everything you did. You see what I'm saying? Okay, so this is the guess and check method of factoring. When we want to factor a binomial, factoring out the GCF, and then identify whether it is a difference of squares are our only steps. So that's what we did last time. In 6.1 and 6.2, we factored out the GCF, remember that? And then we factored difference of squares. When we go to factor 4-term polynomial, we'll factor out the GCF. That's always the number one rule. And then we try factoring by grouping. So that was what we also learned in 6.1 and 6.2. Thus, our next step is to focus on the case of trinomials. So we're talking about a trinomial here, and what is this? A leading coefficient of 1. So normally we say ax squared plus bx plus c. We call this a quadratic, and it's a trinomial. It's quadratic because of the second power. Have you heard that term before, quadratic? okay? X squared makes it quadratic, or you could say degree of 2. The leading coefficient in this case is 1. A is equal to 1. A is the leading coefficient. Remember when we were going over that with polynomials, leading coefficient, okay? Recall the distribution method used to multiply two binomials, which we just did. That's FOIL, right? X times x is x squared. X times n is nx. M times x is mx. M times n is mn. So our middle two terms are what we call like terms. And those two numbers, the m and the n, are going to add together, right? That's where we got the idea of, on the last problem where we were looking at, we were adding those two numbers together, m and n. And then for the last one, we're multiplying them. So here's the sum, and here's the product of m and n. Many trinomials will factor into two binomials just by finding the correct combination of m and n values and working backwards from the above formula. To determine m and n, we're going to look for two numbers that add to m plus n and multiply to mn. And that sounds like a lot of like, what are you talking about? M and n. All right, well, let's get some actual practical examples. This is what is meant by trial and error. We have a good idea of what type of numbers we should get for m and n, but to find them exactly, we need to guess and check. Try out the following. So here, what we're looking for is we're looking for two numbers that multiply, so I call them factors of negative 15 that have a sum of 2. And it's kind of like a game. This is really, you guys, where I started loving math. It actually is when we were learning how to factor, because it really is like a puzzle. And I like doing it in my head, but a lot of people like listing them out. And this is where your times tables are critical. So I have the fill in the blank times tables. Brushing up on your times tables can only help with factoring. So let's think about two numbers that multiply to negative 15. Come up with any pair that you want. Negative 5 and 3. If you add those two numbers together, what do you get? You get negative 2, actually, right? Because you owe more than you have. So give me, that's not quite it. So can you give me two more factors of negative 15 that would add to 2? So two numbers that multiply, you almost got it. It's just we want a positive 2. So what could we do to change this to a positive? Yes, negative 3 times 5 is going to add to a positive 2. So those are your numbers, x minus 3, x plus 5. That's it. Okay. Now, the pattern that we saw on the previous page, we said if it ends in a negative, we know the signs have to be opposite, right? And if it adds to a positive, the bigger number has to be positive. That's what I was talking about on the previous page about those patterns. So let's look at this one now. We know the number has to multiply to negative 6. Okay, so we want factors of negative 6. What's the sum need to be? What do the numbers need to add to? They need to add to 1. Where am I getting the 1? Yes, sum is 1, okay? So, give me two numbers that multiply to negative 6. Negative 2 and 3. What do they add to? Ding, 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 you found it on the first try. So now we go ahead, we know it has to be x times x gives us x squared. Negative 2 times positive 3 gives us the negative 6 in the end, right? And then the outside, so we can always check by FOIL. The check really means to FOIL and make sure it works, right? If I FOIL this out, I'm going to get x times x, that's x squared. Negative 2 Positive 3, that's going to give me 1x. Negative 6, right? That's our check. But this is our factors. Okay, let's do this one. This can get really fun, you guys. I promise. Yes. Yeah. That does not matter at all because you're talking about, so you're asking, is this the same thing as x minus 2 and x plus 3? And it is, because a times b is the same thing as b times a. We call that the commutative property of multiplication. Commutative, should write it down. Commutative property of multiplication. Says that we can multiply them in any order. So yes, that's exactly right. Okay, now let's look at this one. Two numbers that multiply together to give us negative 12 and have a sum of what? So we want factors of negative 12 that have a sum of negative 1. Can you think of those two numbers? You don't have to think of them right away. You could start going, negative 6 times 2. Okay, that would add to negative 4. That's not right. Negative 4 times 3. Oh, that adds to negative 1. So we have x minus 4, x plus 3. How could you check to see if it's right? FOIL. So you would check by FOIL. Okay, how is this problem different than this problem? This one looks almost the same. I'm still going to find factors of negative 12, but this time I want a sum of what? Positive 1, because 1 is the coefficient of x. Good. Can anyone tell me what those two numbers would be? Oh, so the only thing different here is that the 4 is positive and the 3 is negative, right? Does everybody understand the difference between, do you see the difference between these two problems and the answers that we got? Yes. Yes? Ask me. Yes? Are you talking about for this one or this one? D. So you're going to FOIL it. Okay, to check it, x squared minus 3x inside plus 4x last minus 12. What'd you do wrong? Oh, okay. Okay, and then we would combine like terms. Now here, we're going to go back to the strategy. What's the number one rule of factoring? Number one rule of factoring. GCF. So we always want to look. I didn't do that on any of the previous problems because I could tell they didn't have. But does this have a GCF here? Is there anything that they all have in common? They're all divisible by 3. So we would factor out the GCF first. So we're going to bring the 3 out. If you divide everything by 3, you're going to get x squared, what? Plus 6. Okay, now that we know how to factor with the leading coefficient of 1, we can factor this. So I'm looking for, tell me what I'm going to look for. Factors of what? Factors of 6 that have a sum of what? Negative 7. Can you figure out what those two numbers would be? Six and 1. 6 times 1 gives you 7. Both of them are negative. Negative 6 times negative 1. Negative times a negative is a positive, and that would add to a negative 7. There I have the right signs. So I have the 3 on the outside, and then I'm going to break down x times x gives me the x squared. Negative 6 and negative 1 are going to multiply to a positive 6, and they're going to add to a negative 7. The middle term is the added, and the last term is the multiplied, okay? And we can always check that. Now, if I wanted to check, what I would do is I would actually FOIL this first, and then I would distribute the 3. I would just basically work my way backwards like Hansel and Gretel, right? I'm going to work my way backwards. So now you guys really need to try like a ton of these problems. So I'm just going to make up one on the fly, and then you're going to have a ton of them to do on Connect Math as well. Let's do this one just while I'm thinking of it. X squared plus 13x plus 42. This is one of my favorites. Can anyone think of the factors? And again, you don't have to make the table. You can make the table if you find it helpful, but sometimes it's kind of fun just to think about, well, what would those numbers be? So you're thinking of what two numbers multiply to 42 and add to 13? 6 and 7. So it's going to be x plus 6, x plus 7, right? How is this problem, now I'm running out of space, so I'll just move this piece of paper over. How is this problem different if I say x squared minus 13x plus 42? How is that one different than the one I just did? Times negative 7. Because a negative times a negative gives us a positive. What if the problem looked like this? X squared minus x minus 42. Now what would the factors be? Still 6 and 7, but what about the signs? Oh, so which one is, both of them have to be opposite, or they have to be different signs. Which one should be negative? Yes, because you end up with a negative 1, right? So I have to be negative 7 and a positive 6. How is this one? I know, do you know what I'm going to change now? Do you see the pattern? Yes, the negative now is on the 6 and the positive is on the 7. And again, it doesn't matter which order so long as I keep the sign with it. So I could have written it like this, x plus 7, x minus 6. Anyway, try lots and lots and lots and lots of problems, okay? And really just make them up maybe even.